Well, hi, Aslam class. Welcome to your response video for maths. Now, all this week we've been looking at equivalent fractions this week, and what has come up in the video today is there's one or two of you that are still not 100% sure on equivalent fractions. So I went through on the slides, and I'm going to show the example that I did on the board a couple of times. So the first example I showed you was using the bar model. Okay, and what I did, we had this bar, okay, and we split this and we called this bar 1/2. Okay, so this bar was a half. Now underneath, I then drew two more bars underneath, and these are what we call quarters. So as a fraction, the top bar we would write as 1/2. Okay, there are two parts in total, and we write 1 as our numerator. Our bottom one here, we've got 2/4 out of 4 parts. Okay, so you can see that they are exactly the same length, therefore, and the same size, therefore, 1/4 is 2/4, sorry, are the same as saying 1/2. So that's how we can see it in a bar model. The other model I did was about 2 pies, okay, and I told you a little story. So one day, Mr. Langford, or me, I cooked 2 pies. One pie is apple pie, and one pie is a cherry pie. Oh, it's making me feel hungry. Right, the apple pie is this one over here. Okay? I'm just going to write apple down here and cherry down here. So my apple pie, I decided to, once it's cooked, I cut it into 8 equal parts. So now my pie is in 8 equal parts. So as a denominator, I've got 8 parts. So my denominator for this pie is going to be over 8. All right. My cherry pie, I cut into quarters instead. Okay, so now my cherry pie is cut into 4s, so that means our denominator is going to be 4. All right. Now, I then eat. On one day, I eat apple slices. I have 1, 2, 3, 4, 5, 6. I've eaten 6 slices of my apple pie. So that is my numerator, and I put that at the top. So I have eaten 6 slices out of total of 8 parts of my apple pie. The next day, I feel a bit peckish, and I go, I'm going to have some of the cherry pie instead for today. So I start eating my slices, and I eat 1, 2, 3. Yum, yum, yum. So I've eaten 3 slices. So now my numerator over here is 3. I've eaten 3 slices of cherry pie at a total of 4 slices. I then asked the question, which pie have I eaten more of? And it stumbled some of you because you're thinking, well, they look the same. And it wasn't a trick question. Of course it's the same. Look, I've shaded in exactly the same amount in these pies. It's just this one has been split into 8 pieces, and this one has been split into 4, but I have eaten exactly the same amount, and you can see that quite clearly. Okay, I've eaten the same amount of cherry pie as I have the apple pie. It's just that these were 4 big slices, and these were 8 smaller slices. So I ate 6 smaller slices here, but I've ate 3 big slices here. Same amount, different fractions, but these fractions are representing the same amount. So we call these equivalent fractions. 6/8 is exactly the same as 3/4. So I've eaten the same amount as apple pie, I had cherry pie, and the fractions just look a bit different because of the way we split the pie up, right? But you can clearly see here that the shaded colors are exactly the same. I've eaten the same amount of pie, so the fractions are equivalent. They are the same. Just going a little bit further than that, because some of you may find it easier doing it this way. equivalent fractions, if you can find equivalent fractions by multiplying a fraction or dividing the numerator and the denominators of a fraction as well. And let me explain that. So let's say I had 1/3. Okay, I can find equivalent fractions for 1/3 if I times the numerator, let's say by 4. Whatever you do to the top, you have to do to the bottom. So I could then times my third by 4 as well. Okay, and that gives me a fraction of 4/12. 4/12 is the same as 1/3. And if you were to draw that in a picture, you could do that and work that out yourselves. It's exactly the same. And that's just a way of showing it. Another one, let's do 4/8. 4/8, okay? Let's times 4, let's times it by 5 if we wanted to. So we could times this whole fraction by 5. And you would get 20/40. 20/40 is the same as saying 4/8. All right, and let's work in reverse then. So they're equivalent. But I could have 4/14. What number can I divide into both 4 and 14? The answer is 2. So if I do 4 divided by 2 and then 14 divided by 2, that will give me the equivalent fraction for 4/14. 4 divided by 2 is 2, and 14 divided by 2 is equal to 7. So 2/7 are the same as 4/14. This is a more abstract way of doing it, all right? But it may just help you if that's the way you think. Let's try another one. Let's do let's do 6/12. Okay, what can I divide 6 by? I can also divide into 12. I could divide 6, couldn't I? I could divide 3. I could divide 2 into all of these numbers, but I'm going to go with 6. So 6 divided by 6 and 12 divided by 6. So whatever you do to the numerator, you do to the denominator. The same calculation there. 6 divided by 6 is 1, and 12 divided by 6 is 2. So 6/12 is actually a half. Okay, and if you have a look at a wall chart, a fraction wall chart, you would be able to see that as well. Hopefully that clears that up. And yeah, you'll be glad to know we're still doing fractions next week. So, but we're going to do, we're not looking at equivalence next week, but you know, replay this video over and over again until you get it. All right, then guys, see you in the next one. Bye.